All right, today we're going to talk about some exponents. So you're going to work along with your properties of exponents packet and do a couple of examples, and then your job will be to finish and fill in the rest. All right, so just an introduction to exponents. Exponent is a number multiplied over and over and over again. So if we look at number one, we have x times x times x times x times x. So that's five x's. So we'll say x to the fifth power. That exponent tells me is x times itself five times. Okay? So different parts of an exponent. If we look down here, we got 5x squared. We're going to say 5 is the coefficient, the number in front of the variable. X is the base. So anything being raised to the power is called the base. And 2 is the exponent. That is how many times we multiply the base by itself. All right. So some rules. First, a monomial. Mono means one, so it's an expression containing one term. So an example of a monomial would be x, 2, 4, 7, y, whatever has one term. So when you multiply monomials, you're going to have some special rules. So you're going to keep the base the same. So they have to have the same base. So in this case, both of these bases are a. So we keep the base the same. You're going to add the exponents. So you're going to add how many there are. So you got 2 plus 3 would be 5. Why is that? Because it's a squared is the same thing as a times a. Multiply, keep that multiplication sign. So this is the first part. And then a cubed is a times a times a. So a to the third power is 3a's. So this is the second part. If you count all those up, you get 5 total. So that's where that comes from. That's why you add them. So you add the exponents and you keep the base the same. Okay, so first example with a to the third power, b to the third power times a to the second power, b to the fourth power. We want to focus on the letters that have, or the letters that are the same, or the bases that are the same. So we're going to start with the a. We get a to the third power times a to the second power. And we're going to get a to the fifth power. Then we'll look at the b's. So we got b to the third power times b to the fourth power. And you add those exponents, add the exponents, and get b to the seventh power. So I could write this as a to the fifth, b to the seventh. And that would be my final answer. Separate the two first, and then put them together. All right, so that's multiplying exponents with the same base. Add the exponents. When you multiply, you add the exponents. Dividing. So dividing is the opposite of multiplying. Then we do the opposite of addition, which is subtraction. So we're going to take a fifth power minus 3, and that becomes a to the second power. Where does this come from? If I rewrite this, the top part would be 5 a's times each other. We would get a to the fifth power. And the bottom part would be a to the third power, because we have 3 a's times each other. Now would it cancel out what appears twice? 1, cancel out 2, cancel out a third. How many a's am I left with? Just 2. So that's where the a to the second power comes from. So remember, you subtract the exponents. All right. Whichever has the largest exponent. So whichever has the largest exponent, it goes to the top or the bottom. So if the bottom has the largest one, it stays at the bottom. If the top part, the numerator has the largest exponent, it stays at the top. An example of this would be if it was x to the fourth power over x to the seventh power, you're going to get 1 over x to the third power, because this is still 7 minus 4, but we'll go to the bottom because the bottom part has the highest exponent. Okay, so looking at number 1, same thing as we did before when we multiplied. We're going to separate these. We're going to say a to the fifth power over a, and b to the eighth power over b to the fifth power. All right, now if there is no exponent there, we could assume that it is 1. So we're going to say a to the 5 minus 1 equals a to the fourth power, and b to the 8 minus 5 equals b to the third power. So now I put those together. I get a to the fourth b to the third. And that's my final answer. In 2, we have to think about what's on the bottom and what's on the top. The x's, the higher one is on the bottom, so that means there's going to be the x at the bottom. The y's, the higher one's on top, that means there's going to be a y on the top. And for z's, the higher exponent is on the bottom, so that means there's going to be a z on the bottom. Now do the subtraction. 3 minus 2 equals 1, so that means the exponent for x is 1. 4 minus 2 for the exponents for y is 2, so that means the exponent for y will be 2. And then for the z, it's going to be still 4 minus, remember there's nothing there, we put a 1, 1. So that is 3 as the exponent for z. So make sure they're in the right spot, the numerator or denominator. Do your subtraction and then put the exponents together. Try the next ones on your own. All right. If you're adding, it's different than multiplying. If you're adding, there are no special rules. They have to just be combining like terms. So are these like terms? Answer is yes. How many of them are there? There's 2. Therefore, we could say there's 2a squares. Are these like terms? Yeah, they are. How many of them are there? Well, there's 3 of these and there's 5 of these. So we're saying 3 plus 5 equals 8 a squared b's. Are these like terms? No. No more you can do. All right. You guys try these ones on your own. Next, we're taking a power to the power. So we're taking a power to the power. We're going to have to multiply. So what that means is we're going to multiply. We're going to multiply whatever's on the outside of the parentheses to each of the exponents. Remember, we want to make sure there's always an exponent shown. So if there's a b alone, we could put a 1 there. So we want to make sure we distribute that 3 to each of the exponents. So it's going to be that 3 is going to be distributed to 2. So it's going to be like a squared to the third power, and it's going to be like b to the first power to the third power. Now we're going to combine these. Whenever you have a power raised to a power, they're multiplying. So you're saying a squared times 3 and b to the first power times 3. You simplify those, you get a to the sixth power, b to the third power, and that ends up being your final one. All right, where does that come from? You get a squared, which is the same thing as saying a times a to the third power. That means you want to repeat this 3 times. So you're saying a times a times a times a times a times a, and you end up getting a to the sixth power because it ends up being 6 of them. So the key thing is distribute the outside exponent to each of the inside exponents and you multiply. So you get a to the 4 times 2 power and b to the 3 times 2 power. So you get a to the 8th, b to the 6th. All right. For more intense, you just divide them up. Do the distribution first. So you get a to the 2 times 2 power and y to the 4 times 2 power. Do the same thing over here. All right. You get x to the 3 times 3 power. And you get y to the 2 times 3 power. You're going to get x to the 4th power and y to the 8th power. Here you get x to the 9th power and y to the 6th power. And now you could add those exponents together. So you get x to the 4 plus 9 power, which is x to the 13th power, and y to the 8 plus 6 power, which ends up being y to the 14th power. So that's your final answer. Now when you're dividing, same process. You still distribute to each of those exponents. So you're going to get a to the 10th power over a to the 6th power. Subtract those, you get a to the 4th power. Same process.